Now this next lesson will teach you another word, normal. We know tangent to a curve is that line which just touches the curve, while the normal to a curve is that line which is perpendicular to the drawn tangent. So we need the knowledge of previous work of how to find a perpendicular, but because this is to a curve for a tangent, we need the knowledge of dy by dx as shown in previous lessons. So let's put this into practice. So to work out the tangent, as before, we work out the gradient first of all, which will be 2x take 2. At -1, the gradient will be, put -1 in there, 2 minus 1 is minus 2, the gradient will be -4. So for the tangent, we have y minus 3 will equal the gradient x minus -1, x plus 1. Remove the bracket. And then, arguably, I'd bring all this over here. So y, add the 4x, add 1 equals 0. There is your tangent. As for the normal, as I pointed out on the previous, the normal is perpendicular to the tangent. So the gradient of the normal will be a quarter. So we have y minus 3, just as before, but it equals a quarter x plus 1. It's just the gradient that's different. Take the 4 across because I don't like the fraction. We've got 4y take 12. 1 times x is 1x, 1 times 1 is 1. And here I just take the 12 across. So 4y is equal to x add 13. There's your normal. Okay, so to work out the tangent again, we need dy by dx. So that gives us 3x squared, 8x minus 8. So when x equals 2, the gradient will equal 3 lots of 2 squared, 8 lots of 2, and take 8. So that is a gradient of 20. We have not been told the y coordinate here, so for speed I'll use the calculator. We have got 2 cubed plus 4 lots of 2 squared. Take 8 lots of 2 plus 2, which comes out to be 10. So the tangent has equation y minus 10 equals 20 lots of x minus 2. Remove the bracket, take the 10 over, tangent. As for the normal, very similar. However, if that's the tangent's gradient, then the normal will be minus 1 over 20. If I take that across the other side, it becomes times 20. And I'm left with then minus 1, so minus 1x, minus 1 times minus 2, plus 2, and arguably I could take everything across to that side, so I get 20y plus x minus 202 is equal to nothing. So this example is actually a past paper question, tangent and normal. So we start with dy by dx. 2x, take 4. So when x equals 1, the gradient will equal 2 take 4 minus 2. So the tangent is y minus 4, because the y coordinate's 4, equals minus 2 lots of x minus 1. Remove the bracket. And again, move everything across. So y plus 2x minus 2 becomes minus 6 with the minus 4 equals 0. And there's your tangent. As for the normal, very same setup, with except for the gradient, because the gradient will now be the perpendicular gradient, which is a half. Take the 2 across the other side as a times 2. So it just leaves us with the 1x minus the 1. Hence the normal, if I just take the 8 across here, we get 2y is equal to x plus 7. So there's your tangent, there's your normal.